Two events A and B are called independent if the occurrence of one does not affect the probability of the occurrence of the other. If the events are independent, you will use the formula P A and B, which is just equal to P of A times P of B, probability of A times probability of B. So how would that look in practice? Let's say you wanted to pick two cards out of a well-shuffled deck, and those two cards happen to be aces. You want to select two aces. You select one card, mark down what it is, and then put it back into that deck. Then you select another card, mark that down. This is an example of an independent probability because each time you select a card, it is the same probability each time. And the biggest thing here is because you replace the card you drew first, that makes it independent. But what does that look like when you're doing the math? Well, we know that in a deck of cards, there are 52 of them. And that there are specifically 4 aces in a deck of cards. So when you are trying to find whether the first selection and the second selection are aces, we're going to use these facts here. So we know that there are 4 aces in a deck of cards, so 4 divided by the total number of cards in a deck, 52. So you've gone in, you've selected it, and you pulled out an ace. Very good. You take that ace now, put it back into the deck, and reshuffle it, and now you're going to select another card. And this time, it is again an ace. And again, there are 4 aces because the card you drew out, the ace you drew out, you replaced it. And because you replaced it, there are still 52 cards in the deck. So all you do from here is you're just going to do 4 over 52 times 4 over 52. And when you do that, you're going to end up getting a decimal, a fraction as well, but a decimal is usually better in this case, of 0.0059. Not a very likely chance that you're going to select 2 aces in a row, but still possible. This is what happens when you replace an ace. This is what happens when you have an independent event. Now, let's do dependent and see how it looks. Two events A and B are dependent if the occurrence of one does affect the probability of the occurrence of the other. If the events are dependent, you will use the formula P A and B is equal to probability of A times the probability of B given A. So this is where something does affect the other. So let's see it in action. Same rules apply, same question. You're going to select 2 cards out of a deck. You want 2 aces. The difference here is once you select one card and mark down what it is, you're going to keep that card with you. It does not go back into the deck and nothing replaces it. Then you select another card, mark it down, and then you figure out the probability. This is again a dependent event because the second time you select a card, it's changed from the first time when you selected a card. The biggest thing here is you didn't replace the card you drew. Now, what does that look like when you do the probability? Well, we know, again, from a deck of cards, we have 52. And we know we have 4 aces. So, the probability of selecting an ace your first time around from a full deck that's shuffled is 4 out of 52. Now remember, you've selected that ace, you know that it's there, and now you're putting it off to the side. It's no longer in the deck. This deck now has only 3 aces left, so we can say we have 3 aces left to choose from, and since you've again selected one card from first and put it off to the side, we only have 51 cards left over. So you can see here that the event of the first one, the first ace drawn, 4 out of 52, affects the second card drawn, the 3 out of 51, because when you've drawn it, you have changed the probability. You didn't replace it. So when you multiply these together, 4 over 52 times 3 over 51, we're going to get 0.0045. So a dependent event changes the probability from the first event to the second event, whereas an independent event does not change. So we can see both of these together, that while the probabilities are not too far different, 0.0059 and 0.0045, it is enough to change the probabilities and make it a completely different answer. So you need to be careful whether you're having an event that is independent or something that is dependent.